Welcome you all to Principles of Organic Synthesis. At present, we study aromatic diazonium salts. In this topic, so far we had one lecture where we studied the preparation of diazonium salts, the possible reaction pathways, where we have seen three types of reactions. If the anion is weak nucleophile, then the diazonium salt can undergo reaction with strong nucleophile like cyanide ion. It can undergo addition reaction to nitrogen. Similarly, it can also undergo reaction with water, we have seen. Then we have seen the reaction that involves carbocation intermediate. For example, if you heat the diazonium salt, it can convert into aryl carbocation, which can further undergo reaction with the nucleophile. We have seen some examples. Then we also saw the reaction that involves radical intermediate. For example, if you have the diazonium salt, if you try to react with copper 1 salt, the copper 1 salt can reduce by single electron transfer process the diazonium salt into aryl radical, where the copper 1 salt will be converted into copper 2. The aryl radical can further react with the copper 2 salt to give the corresponding aryl halide as a product, where you will regenerate the copper 1 species. We also have seen some examples for the Sandberg reaction. In continuation, today we will see some more reactions of diazonium salts. The first example involves the reaction of diazonium salt, the aromatic system. Here the reaction of the diazonium salt with the benzene ring is shown. In the presence of aqueous sodium hydroxide, you can try to couple them to give this biaryl system as a product. If you look at the reaction, it involves biphase system. You have to take this salt in aqueous sodium hydroxide, then you have to take the benzene, then you have to carry out the reaction, then you will be able to get this biaryl system. If you look at the reaction pathway, here the diazonium salt first undergoes reaction the addition product, which can exist as I mentioned earlier in geometrical isomers. Once if you have this one, this also can undergo further reaction with another molecule of diazonium salt. You will be able to form, for example, if you take here, then it can this is a product. So HCl will remove it, so you will get this compound. Once you form this one, which can undergo homolytic cleavage, to produce radical plus this radical. Once we form this aryl radical, which can react with benzene, so you will be able to get for example, in this case you will get this radical intermediate. As all of you know, this you can write in the resonance form. This radical, once you form this one, now already you have the radical in the reaction medium. This radical can so you will be able to the biaryl and get this species. If you look at this reaction has limitation, and if you have, for example, symmetrical substrate, then in this case if you have the symmetrical or simple benzene, you will be able to get this product. On the other hand, if you have the substituted benzene, for example you have the substituent, so the reaction can take place ortho position, meta position, para position, then you will be able to end up with a mixture of compounds. On the other hand, if you have the, for example, a symmetrical substrate, then you will be able to selectively react this carbon or this carbon, then you will be able to get a less number of products. On the other hand, if mono substituted, you will get a mixture of compounds. See, the best way to make biaryl system, you can start with peroxide as, for example, when you heat this one, already we know that it can undergo cleavage to the peroxide radical. This can lose carbon dioxide to give, this can couple, you will be able to get the biaryl. Wherever you have difficulty preparation of the peroxide, you can try to use this method. However, as I just mentioned, this also has limitation. You will end up with a mixture of compounds. You have to carry out the reaction with selectively particular substrate. So, as I mentioned, this reaction usually carried out in biphase system. You have the benzene, and you have to take this salt in aqueous sodium hydroxide. First you form this one. Once you form this one, and then the reaction proceeds through radical pathway, you will be able to get the biaryl system as a product. Here another example, and as just we have seen the Gomberg reaction, you can also try to, for example, if you have the diazonium acetate, so this also can be reacted with aromatic system to give the biaryl system. They usually have to take N-acetyl nitroso derivative. If we take this one in acid medium, it can convert into this can cyclize once we form this one, this can convert into so you can try to make diazoxate as shown here. If you have the N-acetyl nitroso derivative, which can, when you the reaction medium, in the presence of acid, it can undergo rearrangement to give this diazonium acetate as a product. This reaction also, when you take this diazonium salt and react with and you will be able to, it can undergo addition reaction as we have seen. You will be able to have so let me write A prime. So once you form this one, now this as just we have seen, it can undergo homolytic cleavage to give the aryl radical. So once if we have the aryl radical, as just we have seen, if we have the benzene, for example, it can undergo reaction. For example, if you have the benzene, it can undergo reaction as just we have seen. This intermediate which can now react with this radical. When you add this radical, this can take this hydrogen, you will be able to the biaryl product, and this one in the presence of, since you have the acetate in the reaction medium, the acetate can, when you have the acetate OAC minus, it can deprotonate this proton and you will be able to generate the O minus, which can further undergo reaction with the diazonium salt. The reaction can be facilitated like this. So if you have diazoostate that also can undergo reaction with aromatic system, this also the reaction also involves a radical pathway. If you compare both reactions, the Gomberg and this diazoostate, both reactions have limitations in their application, as I mentioned just now, and the yields are very less, and always you end up with a mixture of compounds. And for example, if you have the monosubstituted benzene, then you will end up with a mixture of compounds. And therefore, if you want to make biaryl system, always try to prepare from the radical pathway using the peroxide. In case if you have difficulty to preparation of the peroxides, you can use these methods to prepare the biaryl system. The next example is the intramolecular cyclization of the system. This is a show reaction, and if you have the diazonium salt, it can undergo cyclization to give this cyclic system, and depends upon the reaction conditions. Now let us look at the mechanism of this transformation. Already we have studied the Perkin reaction. First, the reaction of nitrobenzaldehyde is shown. Nitrobenzaldehyde with phenylacetic acid in the presence of acetic anhydride give this condensation product. This reaction involves, as we have seen earlier, you can try to draw the mechanism of this reaction. Phenylacetic acid can undergo reaction with acetic anhydride. Once you form this one, this can convert into plus acetic acid. Already we have seen the reaction pathway when we discussed about the Perkin reaction. Once we form this one, now this can undergo condensation with the aldehyde, and since you have the acidic medium, protonation of this aldehyde followed by enol of this carbon can lead to the condensation to give now this can lose water molecule This, since you have the acid and water, it can undergo hydrolysis to give corresponding carboxylic acid as the product. So once you form this one, you can try to reduce the nitro group. As we have seen earlier, you can use a variety of methods. For example, you can use tin HCl, or you can reduce the nitro group to NH2 group. Once if you reduce this one, then you can try to react with sodium nitrite and HCl. So you will form the nitrous acid, which can convert into the amino group into the corresponding diazonium salt. Once you form the diazonium salt, depends upon the reaction conditions. For example, if the reaction condition is acidic, so it can convert into the carbocation. If acidic medium, the diazonium salt can convert into once you form this one, as we have seen earlier, it can act as an electrophile, it can act as a nucleophile, it can undergo cyclization. So this can lose proton, then you get the so when you heat, can undergo decarboxylation to give this cyclic compound phenanthrene. The product. On the other hand, if the reaction media is neutral or basic in nature, what you can do, once you form the diazonium salt, you can try to react with copper powder. So this can convert the diazonium salt into radical, as we have seen earlier, where copper 0 will be converted into copper 1 by single electron transfer process. We will be able to get this radical. Once if you form the radical, as just we have seen, it can undergo cyclization. is the radical. So this can now, as just we have seen, and since you have the copper 1 will be reduced to copper 0, where this will be oxidized to so you can convert into as once you form this one, as just we have seen, it can undergo decarboxylation when you heat, and you will be able to get the phenanthrene as a product. So this reaction is one of the effective synthetic route. If you have the diazonium salt, you can try to cyclize intramolecularly. You will be able to get this compound. In this place, you can have variety of substituent. Reaction is quite gentle, and we will see some example later. As just we have seen, the reaction medium is crucial. For example, if you have acidic medium, the reaction involves a aryl carbocation which undergoes reaction, is actually electrophile, which can access a nucleophile, can undergo aromatic electrophilic substitution intramolecularly, then you will be able to get this compound. On the other hand, if the reaction is neutral or basic in nature, so you can add copper powder, which can convert the diazonium salt into radical by single electron transfer process, as we have seen earlier, and where you will produce copper 1, which can be later reduced to copper 0, and then you will be able to convert the radical into the cyclic compound. Once you form this one, when you heat, and the decarboxylation can take place to give the cyclic compound as the product. Here some examples shown from the literature. As you can see here, this compound, when you react with sodium nitrite in the presence of sulfuric acid, and you will be able to form the diazonium salt. So once you form the diazonium salt, as we have seen, and this, since you have the copper, it can convert into the radical, it can undergo cyclization, you will be able to get this cyclic compound. The other example shown here, reaction you used sodium nitrite with sulfuric acid. Here the use of nitrite is shown. This also can be reacted in the presence of weak acid like acetic acid, and you will be able to isolate the diazonium salt when you use ether, and this you can make the diazonium salt as we have seen here. Once you form this one, you can try to cyclize, and you can try to oxidize using hydroquinone, you will be able to get the cyclic compound. The next example involves the reaction of this amine with the sodium nitrate HCl. As we have seen earlier, you can make the corresponding diazonium chloride. Once you form this one, you can use the copper. This also can reduce the diazonium salt into the radical. Once you form the radical, which can undergo intramolecular cyclization to give the product. Another example, you can see here this ether, diaryl ether, it has the amino group, which also be converted as just we have seen using the sodium nitrate and sulfuric acid, and you will be able to make the diazonium salt, which can be converted into carbocation, which can lead to cyclization to give this cyclic ether as a product. So as you can see here, this is an important reaction. If you want to cyclize, if you have the amino group, you can make the diazonium salt, which can be readily converted into carbocation or radical that can undergo intramolecular cyclization to give the aromatic compounds. So this is another example. Here the reaction of this diisonium salt is shown here. This can be made from the anthracic acid. Once you form this one, when you use the copper 1, which can, as we have seen, it can reduce to the corresponding radical. If you have the di radical, it can undergo dimerization. You can get this biaryl system as you can in quantitative yield. And the next example involves, in addition to that, you can also, if you have the diisonium salt, and you can also react with other nucleophile. For example, here sulfur nucleophile is shown here, and it can undergo reaction. You can make a carbon sulfur bond, and when you look at the mechanism of this transformation, so let me write S or, once you form this one, so it can undergo addition reaction. Once you form this one, which can undergo, just as we have seen, homolysis to give radical. Now this radical, whatever you have generated here, it can react with another molecule of SR minus. You will be able to form you can write like this. Once you form this radical anion, which can react with the diisonium salt, and you will be able to form the coupled product, and so as you can see, just we have seen this S minus undergoes addition reaction. You get this intermediate. Once if you have this one, which can undergo homolytic cleavage, where you generate the sulfur radical and as well as aryl radical. Once you form this one, this aryl radical can react with the SR minus. So you will be able to have this radical anion, which can react with the diisonium salt to give this coupled product as well as aryl radical, and where you lose nitrogen. Once you form this one, and when you react with the base, it can undergo hydrolysis. In this way, you will be able to get diol as the product. So if you look at all these reactions which undergoes homolytic cleavage to give the radical, that radical further undergoes reaction to give the coupled product. So now let us look at reactions in which the nitrogen is retained. If you see all these reactions so far, we make the diisonium salt. The diisonium salt has been replaced by mostly aromatic carbons. Then we also have seen one example where you can also you can try to react with the sulfur, then you will be able to make a carbon sulfur bond. Now let us look at reactions where the nitrogen can be retained. This one example, if you look at the aniline, and when you react with the nitrous acid, and you will be able to form the diisonium salt as we have seen earlier. Once you form the diisonium salt, now you have the sodium sulphide which can undergo addition reaction. You know the structure of sodium sulphide. So this can undergo addition reaction, then you will be able to form So once you form this one, which can undergo addition reaction with another molecule of sodium sulphide, it can pick up the proton, you will be able to form, let me write, convert into this, then you will have here SO3, so which when you react further with proton, then you will be able to form hydrazine, and so if you have the aniline, it can be converted into hydrazine. For example, in this case you can convert into phenylhydrazine. First you can try to react with the nitrous acid, you form the diisonium salt. Once if you have this one, you can try to react with the sodium sulphide. In this way you will be able to form phenylhydrazine as the product. The next example involves the coupling of dimethyl aniline with diisonium salt, and if you have the tertiary amine, it can undergo a reaction as we have seen here, and it can undergo reaction with the nitrogen. You will be able to get this compound. On the other hand, if you have the primary and secondary amine, they also can undergo reaction as we have seen, and you can get the addition product. Once you form this one, which can further undergo rearrangement to give as the product. As we have seen the earlier class, if you have the, for example, aniline first undergoes addition. Once you form this one, which can further undergo rearrangement, you will be able to get this diazo compound. And if you have the tertiary amine, you will get this compound as a straight away. On the other hand, if you have the primary amine, once you form this one, which can further undergo rearrangement, you will be able to get this diazo compound as the product. Here an intramolecular reaction shown. Whatever we have seen the earlier slide is an intermolecular reaction between amine and diisonium salt. So when you take this phenylene diamine and when you react with nitrous acid, one of the NH2 can be converted into diisonium salt. Here this NH2 has been converted into diisonium salt. Once you form the salt, which can now undergo intramolecular cyclization as shown here, then you will be able to generate benzotriazole as the product. The next example is, as we have seen, the reaction of aniline with the diazonium salt, and similarly you can also try to couple with phenoxide. Yesterday we have seen, for example, if you have the diazonium salt, you can try to react with the phenoxide. If you have the phenol and basic conditions, then you will be able to undergo addition reaction. To get this diazo compound as the product. On the other hand, if you have the substituted phenol, for example, para-substituted phenol, this also can undergo reaction. For example, if you have the diazonium salt, as we have seen, it can undergo reaction at the ortho position. You will be able to, under basic conditions, it will be deprotonated. Then you will be able to form after workup, you will be able to get this. Once you form this one, this can exist like this. So this addition reaction can take place the ortho position. You will be able to get this diazo compound. Now let us look at beta-naphthol. As just we have seen, this also can undergo reaction with the diazonium salt. You will be able to form as the product. So if you have the phenol which can readily undergo reaction, as we have seen, the aromatic carbon can undergo, depends upon the substrate. For example, here if you have the substitution, the para position, the ortho carbon undergo reaction readily with this diazonium salt. For in the case of beta-naphthol, this carbon undergoes addition reaction, you will be able to get this additional product. Here the reaction of enol is shown, and as we have seen, now let us look at this acetophenone having NH2 at the ortho position. When you take this orthoamine acetophenone, react with nitrous acid, you will be able to form this diazonium salt. Since the reaction involves acidic medium, this acetone can exist in the form of enol. Once you form the enol, which can undergo intramolecular cyclization, which can act as a nucleophile and can undergo addition reaction, you will be able to get this diazo derivative. This is known as hydroxycinolene, and if you look at here, therefore if you have the alpha amino acetophenone, when you react with the nitrous acid, you will be able to form this cyclic diazo compound as the product. On the other hand, now let us look at some aliphatic example. Now let us look at the beta keto ester. This also can undergo reaction, as just we have seen when you have the diazonium salt. So since if the reaction medium is acidic, it can exist in the form of enol. It can undergo addition reaction will be able to form so this can tautomerize to the hydrogen derivative. So now this can tautomerize to this diazo derivative. Now let us look at, just we have seen, if you have the beta ketoester, so you can try to react with the diazonium salt. And you will be able to form the hydrazone as the product, on the other hand, if you have the beta ketoester where you have the substituent in this position, when you react this compound with the diazonium salt in the presence of base, and you will be able to form aryl hydrazone as the product. When you look at the reaction pathway, as just we have seen, this beta ketoester in the presence of base, you can form the unolate, once you form the unolate, now it can undergo reaction with this diazonium salt, which can further react with the hydroxide ion to give the addition product. Once you form this one, this can and you will be able to form acetic acid and plus so when you do workup, you can protonate this anion to give the hydrazone as the product. So whenever you have the substituent in the presence of base, it can undergo reaction with the diazonium salt, you will be able to produce this hydrazone as the product. Now let us look at some example from the literature. Now let us just we have seen the reaction of this substituted methyl acetate with the diazonium salt, and you can get this hydrazone as a product. And similarly, let us look at this example, this carboxylate, when you react with the diazonium salt, which can undergo addition reaction in the presence of base, as just we have seen, it can undergo addition reaction, you will be able to get this compound. Once if you have this one, in this reaction you can try to react with sodium borohydride. So you will be able to form this intermediate. Once form this one, it can open up and you will be able to form this hydrazone as the product. So, in this reaction, the reaction of sodium borohydride can give this intermediate. Once we have this one, this can open up and you will be able to get this compound as the product. Here the reaction of mesitylene with this diazonium salt is shown here. Here the coupling of less activated aromatic nuclei is demonstrated. As we have seen so far, we have seen the reaction of activated one. Now this also can readily undergo addition reaction, then you will be able to form the diazo compound as a product. The next example on the reaction of androlinic acid shown here. As we have seen in the earlier lecture, this also now in acidic medium in the presence of nitrous acid, you can convert into the diazonium salt. Once you have this one, when you react with the base, then you can generate this intermediate which can lose carbon dioxide and nitrogen to give benzene as the product. If you do not have the nucleophile in the reaction medium, the benzene can undergo dimerization to give this tricyclic compound as the product via 2+2 cycle addition. This is one of the important reaction, as we have seen. Suppose if you do not have to find out whether the reaction involves benzene intermediate or not. So if you can try to do the reaction which clearly shows that the 2+2 cycle addition of this reaction can give this compound, which shows that the reaction involves a benzene intermediate. Here the reaction of an amino alcohol shown. When you react with the nitrous acid, as we have seen earlier, you can form the corresponding diazonium salt. Once you form the diazonium salt, which can undergo intramolecular rearrangement as shown here, you will be able to form the cyclic ketone. You can also try to, once you form the diazonium salt, which is not stable, which can be converted into the carbocation. Once you have the carbocation, it can undergo rearrangement. As you can see here, through ring expansion, you will be able to get the cyclooctanone as the derivative. Here, for example, what you do here, and you start with this cycloheptanol, which has this methylamine as the substituent. Once you have this one, you can make the diazonium salt. So the diazonium salt, once you form this one, which can readily undergo intramolecular cyclization to give this cyclooctanone as a product. Here are some examples are shown. Now let us look at this example. As we have seen, and you can try to react with the sodium nitrate in the presence of sulfuric acid, you will be able to form the corresponding diazonium salt. So which can you will be able to form this bicyclic ketone as a product, as a major compound. On the other hand, here also shown, and another rearrangement. So here another example you can look at here, as just we have seen, you can make the corresponding diazonium salt. once you form this one, which can now this can undergo reaction here, then you will be able to form this compound. On the other hand, suppose if this bond migrates, on the other hand, this bond migrates here, then you will be able to get this tricyclic ketone as the product. So, as you can see here, this reaction also find broad applications. If you want to do ring expansion, if you have the amino alcohol and you can try to make the diisonium salt. Once you have the diisonium salt, then it can readily undergo ring expansion as shown here, then you will be able to get the ketone as the product. In summary, so in this lecture, in continuation of earlier the reaction of diisonium salt, we have seen the replacement of diisonium salt with by aromatic carbon. First we have seen the Gomberg reaction. If you have the diisonium salt, you can try to couple with aromatic hydrocarbons like benzene, the precursor base, to give the bi-aryl product. We have seen few examples. This reaction, as is shown, it has some limitations. If you have monosubstituted benzene, you will get mixture of compounds. However, symmetrical and unsubstituted aromatic hydrocarbons can be readily reacted, you will get the coupled product. Then we have seen the Shaw reaction, where if you have the aromatic diisonium salt, which can be intramolecularly cyclized to give the phenanthrene, you can get the polycyclic compound. If the reaction medium is acidic, the reaction takes place via carbocation intermediate. Once you form the carbocation, which acts as electrophile, which undergoes intramolecular cyclization to give the polycyclic aromatic compound. On the other hand, if the reaction involves neutral or basic conditions, you can try to react the diisonium salt in the presence of copper 0, which can convert the diisonium salt into the radical by a single electron transfer process, where you generate the copper 1 species, which can undergo reaction. Later the substrate can reduce the copper 1 to copper 0, where the radical intermediate will be converted into the polycyclic aromatic compound. Then we have seen the coupling reactions. If you have the diisonium salt, you can try to couple with amines. We have seen one example for the dimethyl and primary amine, secondary amine based substrates. They can readily undergo coupling reaction to give azo compounds. Then we have seen the reaction of phenol, which also can readily undergo addition reaction. You will get the azo compounds. Then we also have seen the reaction of sulfur nucleophile, which also can undergo addition reaction. Then you will be able to get, in this case, the reaction involves radical intermediate, you will be able to form the CS bond. Then we have seen the reaction of beta keto ester, which can form enol, which can readily undergo addition reaction with diisonium salt, where you will form hydrazone as the product. And on the other hand, if you have the methyl substituted beta keto ester, then we have seen it can undergo rearrangement. You will be able to get the corresponding hydrazone as the product. Later we have seen the ring expansion of amino alcohol. If you have the amino alcohol, you can try to react with the nitrous acid, you can form the corresponding diisonium salt. Once you form the diisonium salt, which can in acidic medium readily undergo rearrangement to give the ring expansion, mostly you will end up with the ketone as the product. We also have seen some of the recent literature examples which reaction finds broad utilities. If you want to convert cyclic alcohol into the corresponding cyclic ketone, you can try to use this reaction. You can convert into the diisonium salt, which can be further converted into the corresponding ketone as the product. With this we conclude this lecture. Thank you very much.